day to all of you. This is a session where we are going to cover the content related with the intermediate, which will be helpful to fetch on the international floor regarding entrance or any competitive examination, India level JEE advanced and JEE mains examination for IIT and NIT entrance examination, that is the technical domain. NEET chemistry for medical entrance examination all across India, Telangana and Andhra Pradesh MCET examination for technical stream, that is engineering entrance. In addition to all these, if you are aspiring for any government examination, you can definitely clear all the sessions if you are going to observe the session what we are discussing, being it is a part of general studies question paper. Let's enter into our today's session. Explain the geometrical isomerism in the following compound as per the IUPAC protocol. E and Z nomenclature to be mentioned. The compound with the double bond was taken in order to give the name. What are the rules we need to follow? In order to give EZ nomenclature, EZ stands for entagagin and jusamin. E for trans arrangement, Z for cis arrangement will be there. If two higher priority groups are in the opposite direction, we can say E configuration. If two higher priority groups are on the same side, that we can say Z configuration. Then how can we assign this numbering as per the priority? That is given by Kahn-Ingold-Prelog rules. So the first one is about Kahn-Ingold CIP rule is atomic number. Higher the atomic number, greater will be the priority. Chloro is of higher atomic number over carbon. That's the reason why chloro will be accorded with A and carbon will be given with B, right? So this is the way one of the carbon is prioritized. Later on, second double bonded carbon, we need to go for individual priority. Again, here is the carbon, here is the carbon. There is an ambiguity. Both are carbons only. Then how can we assign the numbering? We have to go for further substitution. On the side chain carbon atom, you can find 2 methyl. But on the side chain carbon, only 1 methyl is there. So that 2 methyl of higher priority over 1 methyl. Hence, this isopropyl will get priority A over this ethyl. Ethyl is having priority B. So if you observe, A priority are oppositely inclined, B priority also opposite. If A opposite, that is said to be E configuration. And moreover, we have to go for IUPAC nomenclature for the compound. First carbon, second carbon, third carbon, fourth carbon is having fluoro. So that 4 chloro, let me mention. And third carbon is having ethyl. Why we are writing 4 first rather than 3? Because chloro will be the first letter in the alphabetical order over E. That's the reason why 4 chloro mentioned over 3 ethyl. 4 chloro, 3 ethyl, and methyl is there on, meth is there, CH3 is there on the second carbon. So that let me mention 2 methyl, 4 chloro, 3 ethyl, 2 methyl. Where the double bond is located? Double bond is present on third carbon atom. 3 in will be there. And let me count all the carbons present in the longest chain. 1, 2, 3, 4, 5, 6, 7. 7 carbon chain is the parent chain. So that the entire name will be E, 4 chloro, 3 ethyl, 2 methyl, 3 in hexane. This is the entire IUPAC name included with the EZ nomenclature. This is the way question number 1 will be answered. E, 4 chloro, 3 ethyl, 2 methyl, 3 in hexane is the IUPAC nomenclature for the compound number 1. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. A gas is released at the point Q. Q is the point where gas release is possible as shown in the apparatus. Okay. Here is the strip which is made up of universal indicator paper. A damp universal indicator paper was placed over there, and here is the gas which is diffusing. Which gas changes the color of damp universal indicator paper most quickly? This is the most logical question. There is no any chemical reaction. There is no any physical properties, nothing else you have to put, rather just a logical thinking we have to play over here. Let me repeat the question once again. Which gas changes the color of universal indicator paper most quickly? Right, here are the gases mentioned and their relative molar masses also provided as per your convenience. The gas is ammonia, whose molar mass is 17, carbon dioxide 44, chlorine gas 71, hydrogen gas molecular weight will be 2. This is the way various gases are there. Most of the people will think that the gas which is acidic or else which is basic will pass through this very quickly and neutral gases will not flow. So that is the way they will think, and most quickly the gas either ammonia or carbon dioxide most of the people will go with. But the correct answer is, first of all, let me say, what is universal indicator? The indicator which give the various coloration with the various nature of the substance. pH 1 gives the intense red color and pH 2 with the orange color, pH 3 somewhat a little orange, and pH 4 orange color somewhat pale in nature, pH 5 yellow in color, 6 pH light green, pH 7 intense green, pH 8 bluish green, pH 9 it is a kind of what blue coloration, pH 10 is a intense blue color, pH 12 will be a purple color, pH 14 will be a dark violet in color. This is the way various coloration as per the nature of the substance we are choosing, different coloration the strip will be changed into. So that here the compulsory thing everybody should observe is each pH will have its distinct coloration. Either it may be acidic, neutral, or also basic, but the thing is there is a coloration, there is the color appearance is possible. This part will make the answer, right? Hydrogen gas, if you consider, being it is a covalent molecule, no polarity, neither acidic nor basic, so that it will reach out the pH around 7 only, because being it is neutral, pH 7 is a part of neutral, right? Then that's the reason why hydrogen atomic molar mass is accorded as a 2 only. So the statement here provided, lighter the gas, faster the speed. Being lightweight, atomic mass, if you consider all, hydrogen is lightest gas among all known gases, right? So that hydrogen will move very fastly, so that it will indicate the color. The coloration is possible. After hydrogen gas, the next will be lightweight. After hydrogen, the next level will be ammonia, right? So that next faster running one will be ammonia, followed by carbon dioxide, 44 molar mass, so that next level will be 44 carbon dioxide, and heavier chlorine will be there, 71 molar mass, so that it will least moving very slowly, so that it will give the coloration at the least, right? This is the way a quick gas which is changing the color of universal indicator will be hydrogen. The correct answer will be hydrogen. For question number 2, option D will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2019 question paper, paper 1 question it will be. Which of the following statement is true? More than one statement might be correct, so that is are mentioned. It is the part given from biomolecules, in specific carbohydrates question it will be. The two 6-member cyclic hemiacetal forms D plus glucose called anomers. Anomers are nothing but any two compounds which differs in at only one carbon atom. Differs in configuration at only one carbon atom, they are said to be anomers. So that the D plus glucose exists in two forms. One is called alpha form, second is called beta form. Alpha form is having OH at right hand side, beta form is having at left hand side, so that obviously both are said to be what? Anomers. Hydrolysis of sucrose gives dextrorotatory glucose and levorotatory fructose. Absolutely correct, because sucrose is a dimer. It is called a disaccharide. Upon addition of water, it is a table sugar as well. Sucrose is the table sugar. Whenever water is added to sucrose, it will be hydrolyzed into one fragment called glucose and another fragment called fructose. And they specifically mentioned with their polarity, that means optical activity. Dextrorotatory. Glucose is the dextrorotatory. Hence, we can say glucose is a dextrose as well. Fructose is levorotatory. It will rotate plane polarized light towards left hand side. Left hand side are called levorotatory. Right hand side are called dextrorotatory. Glucose in specific, dextro. Fructose is levo in nature. So that hydrolysis of sucrose will give glucose and fructose. That is absolutely correct. Third one, monosaccharides cannot be hydrolyzed to give polyhydroxyaldehydes and ketones. Monosaccharides cannot be hydrolyzed to give polyhydroxyaldehydes and ketones. Okay, monosaccharide, mono means what? Only one unit is there, no? Being it is one unit, can it hydrolyze further? In order to make hydrolysis, either two, three, more than three should be present. But monosaccharide itself, it is one unit, can't be further fragmented, so that cannot be hydrolyzed is the correct statement what they are saying, and further aldehydes ketones may not be generated, right? So third one is also absolutely correct. Move on to fourth one. Oxidation of glucose with the bromine water gives glutamic acid. Glutamic acid is the compound which is generated which may not be generated from glucose. Rather, glucose on treating with bromine water will give gluconic acid. Gluconic acid should be generated rather than glutamic acid. Option 4 is wrong. 1, 2, 3, all are correct only. 1, 2, 3 are correct only, right? Let me explain in detail about all these. If you see the hemiacetal form is nothing but oxygen was linked over there, and this is a kind of pyranose ring. We can say 6-membered cyclic ring. Pyranose ring will be there. If you observe, one of the hydrogen is indicated up and OH is indicated down. OH, H, OH, CH to OH. So if you compare with another, so another isomer is also provided, where you can find here upside you can find H, which is called alpha. But here OH is mentioned, that means inverted. H is coming down, OH is coming up, which is called beta isomer. And if you observe remaining orientation, OH remains same position, hydrogen also same position, OH again same, CH to OH also same. Only the difference on the carbon number 1. On the carbon number 1, the conformations are entirely changed among alpha and beta, which are said to be anomers. Anomers are the isomers where one carbon conformation is different. So that absolutely correct for alpha and beta isomers of glucose. Move on to second one, sucrose upon hydrolysis, D plus glucose and fructose levorotatory will be generated. This is the way you can clearly observe. Glucose is a dextrorotatory, fructose is a levorotatory, and this is called sucrose. Upon hydrolysis, you are going to break this ether linkage and we will get such a glucose and fructose forms. So this is called disaccharide as well. Sucrose is a disaccharide, hence it will be fragmented to two monosaccharides. So second one is correct. Oxidation of glucose with bromine water gives gluconic acid. Gluconic acid is the correct answer rather than glutamic acid. Let me show. This is glucose, no? Upon treating with bromine water, wherever aldehyde is there, that simply turned into carboxylic acid. So one side carboxylic acid and remaining all are polyhydroxy only. That is called a gluconic acid. That gluconic acid is the correct answer, but they mentioned with the glutamic acid. This is wrong, right? First one is correct, second one is correct, third one is also correct. For question number 3, 1, 2, 3 are the correct answers. This is regarding carbohydrates topic, right? Move on to question number 4. Question number 4 is taken from JEE Advanced 2019 question paper. Paper 1 question, it is nuclear chemistry. The question collected from nuclear chemistry. We are taking decay sequence of a starting material called uranium. Uranium is most abundantly available in India, and it is called element of nuclear importance, which having tendency to release the radiation. That radiation in terms of either alpha particles, beta particles, gamma particles, right? So there are series of fragmentation, series of decay we can notice, and here is the thorium as the what final product we are getting. Let me see. Let me show. Uranium with atomic number 92 and 238 atomic mass it is having. It is of radioisotope. Radioisotope is said to be any element or atom having tendency to release the radiation, right? So this is called uranium. And minus x1, if this is unknown to you, we need to reveal about. Upon releasing this x1, so that thorium nucleus will be generated, a new element will be formed by the release of this radiation, and atomic number decreased by 2 units, 90 it became, and 238 now turned into 234, 4 units of atomic mass. 2 units of atomic number, 4 units of atomic mass decreased. Obviously, the particle which emitted will be helium nucleus. We can simply assume helium nucleus is called alpha particle, right? And this thorium further further releasing that radiation x2. Upon releasing x2, that turned into pallium. This is another radioactive element where atomic number got raised. 90 turned into 91. Ascendancy in the atomic number you can notice, and atomic mass got remain unchanged. 234 remains as 234 as well. So that we can say the particle whichever emitted in the second step will be beta. Beta particle emission always increase the atomic number, unaltered the atomic mass. So that obviously the step number 2 will be emitted by beta particle, that is electron. Thallium again releasing x3, which is unknown radiation we need to reveal, and Z is the unknown compound generated with atomic number 234. 234 and atomic mass got increased by 1 unit, 92 it will become, they not mentioned. So that again x3 will become beta particle, electron as well. And this further converted into thorium. Again you can notice 92 if atomic number is there, that will become 90, and 234 converted into 230. Atomic number decreased by 2 units, atomic mass decreased by 4 units. Again what removed? Alpha particle, that is called helium nucleus, right? So that x4 is said to be helium or alpha particle, so that we will get a thorium nucleus. Thorium, if you observe this thorium 90, this thorium 90, atomic numbers are same, but this thorium 234, this thorium 230. So if you observe any two atoms of same atomic number but different atomic mass, both are called isotopes in nature. Both are called isotopes in nature. This is the way a series of reactions going to be carried. Sequential decay you can clearly observe, and during the decay process, this radiation got evolved. Those are designated as x1, x2, x3, and x4, right? So here, according to this kind of transformation, we need to answer the questions. X1, X2, X3, X4 are particles, radiation emitted by respective isotopes. The correct options are X1 will deflect towards a negatively charged plate. As of our knowledge, what we said, X1 will be helium nucleus, which is called alpha particle. No, alpha particle is of positive in nature, so it definitely moving towards a negative electrode. So that what they are saying in the option 1 is perfectly correct. Move on to second option. X2 is beta. X2 is beta, that only we noticed because atomic number 90 increased by 91. So that beta particle is the correct answer. Second option is also correct one. Move on to third. X3 is gamma ray. Gamma ray is the wrong answer. Rather, again, beta particle it will be. Gamma particle will not give any atomic number change or mass number change. Gamma particle is not the correct answer over there. Z is an isotope of uranium. Z atomic number is 92, right? So if atomic number is 92, what will be the Z? So atomic number 92 element will be uranium. So that isotope of uranium is absolutely correct only. So that what they are saying in the option 4 is correct answer only. So 1 is correct, 2 is correct, 4 is correct, 3 is wrong. Let me give the detailed explanation for this question. X1 will be alpha particle which is positive in nature, so that deflected towards negative radiation. X2 will be a beta particle which will increase the atomic number by 1 unit. X3 will be a beta particle again, so that atomic number 92 will be generated at this position. X4 will be alpha particle. Alpha particle will make atomic number decreased by 2 units. So let me go in detail explanation about these. So helium nucleus is provided like this. At the nucleus, helium is consisting two positive charges and two neutral neutrons, subatomic particles. We can say these are available at the nucleus. Being alpha particle is a positive one, it is slowly deflected towards negative electrode. They are saying in the option 1 is perfectly correct, right? Beta particle always moving towards a positive electrode, because it is electrons only. Beta is nothing but a moment of electrons negative charge, so they deflected towards a positive electrode. Gamma particles neither positive nor negative, neutral in nature, so that they are moving very straight forward, right? This is the way deflection we can clearly notice, right? And a beta particle for second option is correct only. A third one, gamma particle, is a wrong one. Rather, it will be the beta particle again. Z is identified as atomic number 92, so that uranium isotope. So for question number 4, 1, 2, and 4 are the correct answers. And purely it is a nuclear chemistry question. If you have a fundamental idea about alpha particle, beta particle, gamma particle emissions, and nature of these particles or radiations whichever emitted during the decay of element, so we can answer such kind of questions in a logical manner. Move on to question number 5. Question number 5 collected from Telangana Gurukulam degree college entrance examination. This is the amino acid. We can say amino acid is the part which is the basic brick in order to make proteins. Proteins are called polypeptides, which are started from amino acids. This is the hydroxy group containing amino acid, alpha amino acid it will be. It is treated with 2 moles of sodium periodate. NaIO4 is called sodium periodate. Sodium periodate is a strong oxidizing agent wherever oxidized moieties are present in between these two carbon atoms, the bond will be broken. Whenever bond broken at this instance, there will be a mixture of compounds generated. The expected products from this starting material will be, one side we could achieve a COOH CHO. This is already COH existing. Whatever carbon is having in H2 will be converted into CH4, and on either side already we have CH3 that remains as such, and wherever COH is there, that will be turned into COOH. This is the way mixture of products will be generated by this kind of fragmentation. You are going to break 2 bonds over there. Carbon-carbon bond between the COH carbon atom and OH containing carbon atom, and another bond breaking between NH2 and carbon, so that here 2 products will be generated like this. So for question number 5, option number 3 will be the prevalent answer. Move on to question number 6. It is collected from the organic chemistry and the reagent chemistry in specific. We are going to discuss about the question. The product formed in the following reaction is, the starting material is cyclohexene. It will be treated with the sequential reactions. Let's go with the question. Step number 1. Boron BH3 is called boron trihydrate called borane. So THF is called tetrahydrofuran. It is the solvent. THF is the suitable solvent for organic chemistry. How we will go with the water in inorganic chemistry? In the same way, ether, acetone, what we can say, acetonitrile, THF, all these are the benzene, all these are the solvents in organic chemistry, right? NH4OH is called ammonium hydroxide. Aqueous NaOCl will be treated, sodium hypochlorite, right? So these many reactions, if you are going to perform, the expected answer will be a saturated cyclohexane ring containing NH2. This is called a cyclohexyl amine. Cyclohexyl amine will be the expected product. Let me show in a stepwise manner. First of all, BH3 THF. What is the role of BH3? BH3 is a reducing agent. Wherever double bond is located, the double bond will be attached with BH3 in certain manner, which able to give a transition state with a cyclization like this, so that BH2 is added at one carbon atom, hydrogen will be added at another carbon atom. So here is the kind of addition product, BH2H will be generated. So hydroboration is the simple reduction process. You are going to add one hydrogen, right, in the form of H minus hydride, right? So whenever this BH3 in the presence of THF is added, just now we saw one side BH2 will be added, another side hydrogen will be added. Same compound is treated with the ammonium hydroxide. Ammonium hydroxide is able to release what? NH2 minus. See, here the nucleophile is NH2 minus amide, that used to substitute BH2 so that we will get NH2 over there. That product is called what? Aminocyclohexane. Aminocyclohexane is available in the option number 3. There is no way provision for OH formation so that we can cancel out. And double bond remains as such. BH2 is given for one carbon. This we can cancel out. And epoxide formation, we are not going to add any epoxide over there so that we can cancel out option 4. So this is far away from all the false answers, so that directly you can answer if we are having fundamental idea about hydroboration process followed by addition of any nucleophilic reagent over there, right? So for question number 6, option 3 will be the correct answer. By this, the entire session got completed and we gone through the various dimensions of chemistry, and we covered with the problem solving analogy and the criticality of the questions related with the various domains, including physical chemistry, inorganic chemistry, organic chemistry, reagent chemistry, mechanism, stereochemistry, everything got covered over there. IUPAC nomenclature is being specifically mentioned, and this session is really informative and will definitely will give the strength in order to achieve what exams you are seriously preparing for. I'm sincerely requesting you to like the channel, comment and share with the parents, subscribe. Thank you very much for your patient listening.